let's take a look at the frame of functions defined. Okay, so this is the back side, but we haven't got to that yet. We only dealt with the front side. Okay, but we're dealing with functions, so the question was, what is a function? So this is going to help us determine if a relationship in math is a function or not. Okay, now a function has three rules. There's got to be two groups, and when we talk about the two groups, we mean the x and the y value, or the domain and the range, the input, the output, the independent or dependent variables. Okay, those are the two groups. Most of the stuff we deal with has two groups. There also needs to be a pattern. Now the patterns we've dealt with are arithmetic or linear, geometric or exponential, and the neither, which there's a bunch of others that we won't get into. Okay, so that's usually taken care of as well. The one that we really need to focus on is number 3. It's called one-to-one. It's a special requirement. Okay, basically what it says is that for every input there's only one unique output. Okay, so we've got to get just that one output per input. Okay, so if we look at a table, I guess I'm going to have to erase that, won't I? Okay, so on the table, we've got our two groups. Okay, we've got the pattern, so we got to check one-to-one. So the way we do that, does an x value only have one y value? Is there more than one x? Those are the questions. So we've got two functions here, f of x and g of x. Notice f of x, we have different x values and different y values, or f of x values for those x values, different outputs for the input. So that one's a function. Okay, for g of x, notice that we've got two x values, and those x values have different y values. Okay, same input could give me two possible outputs. Okay, we don't like that. That's not a function. Okay, points is similar. You look at all those x values. Okay, are there any repeating x values? If not, you're pretty much set. Doesn't matter if the y values repeat. What about g of x? We've got 2 for the input down there twice. And do we have a different output for those? Yes, we do. 3 and 5. That's not a function. That one is. Okay, if we look at more of a Venn diagram for f of x. Okay, if I give you 0, will you always give me 4? Yes. 1 to 5, 2 to 6, 3 to 6. Now, some of you may look at this and say, no, it's not a function because 2 and 3 are both going to 6. But what you're really having to look at is this. If I give you 2, do you always give me 6 back? Yes. If I input a 3, do I always get a 6 as an output? Yes. That's still reliable. Whereas, look at g of x. Okay, 2 here can either be 4 or 5. That's when it's not a function. Okay, so does your input have one error or more? If it's 1, it's a function. If it has more than 1, it's not a function. Okay, we don't care about the outputs, just the inputs, looking at how they are affected. Okay, now on the graph, it's the same idea. We're trying to look at the x's and see, do we have more than one y? So let's look at this function first. We'll make it red. Okay, so if I pick a point right here, and I go up to my graph, is there only one y value? Yes. What about if I pick one here? If I go up to there, yeah, there's only one y value. Okay. Whereas if I look at the other graph, we'll make it green. If I pick an x here, I've got a y value below and a y value above. That's not a function. Okay, whereas this one is. The way we talk about it is we call it the vertical line test. So you basically take a line, a straight line hopefully, and you run it across the graph. If the graph touches that in more than one place, it's not a function. So say my line's right there. Right here on this graph, it's only touching once. Here, it's touching twice. That's what makes it not a function. Okay? So, just to help you guys out for if you need to copy this down. So, you can hit pause anytime to get this down. So what is a function? Determining if a relationship is a function or not. Function has 3 rules. There they are. There's the table. Venn diagram. Points. talking about the two groups and patterns, and finally the graph. Okay? Now I'm going to talk about the second part, but you can do it ahead of time or not, but here we go. So functions, we're going to talk about evaluating and combining them. So when we use functions to evaluate inputs, that gives us outputs. Okay, the input's the x, the output's the f of x. Okay, and we can combine them using operations such as addition, subtraction, multiplication, division. So first we're going to start out with talking about evaluating functions. So zoom in a bit. Okay. So evaluating functions. So the f of x, that's our output. The x is the input. Okay. The input will also be part of the equation part. So like this, we have f of x equals 2x plus 1. F of x simply means I have a function named f. Its input is x. What is the pattern? It's 2 times x plus 1. That's the pattern. Okay. That gives me the two groups, the input, the output. I see the pattern. And then, if it's 1 to 1, then I tell you that yes, it is a function or not. Okay? So, to solve it, you simply take a number for the x variable, put it in, and then solve to get an answer which is going to be equal to the output. So let's take a look at some examples here. Okay? So, we've got a linear example. F of x equals 2x plus 1. Let's say my input is 0. So I put 0 in for all the x's. Okay? And then I just solve that side. 2 times 0 is 0, plus 1 gives us 1. So f of 0 equals 1. 1 is my output, when 0 is my input. Okay, it's like it's a point. With the x value 0, y value 1. Because it's the input and the output. Okay, for an exponential example, same concept. Okay, f of x equals 2 times 3 to the x. Let's input a 2. Now, on the inputs, you can choose the number if you're using it for something, or sometimes I'll give you the number to choose. So I put, every place there's an x, I put a 2 in there. Then I solve. 3 squared is 9, 2 times 9 is 18. There's my answer. For my input of 2, I get an output of 18. So f of 2 equals 18. Okay, now here's another type of example. Okay, a neither pattern. Now notice I have two n's here. When I input the 1, I input 1 into every single n. So I get 1 plus 1 plus 1, so 3. So g of 1 equals 3. If I graph this up the point 1, 3, I have my graph there. Okay, so there we go with that. That's simply the evaluating part. Okay. Now let's kind of look at all the rest of it is when we're combining functions. So combining functions, kind of tables, graphs, equations. Basically, we've kind of dealt with when f of x equals g of x. What that means is where do they intersect? Okay, and often they'll put stuff like f of x plus g of x minus g, times, divide. Okay, so basically what you most of the time what you do is you find the outputs and then combine them in that way. Okay, so if we make a table, now I made my table with 3 columns to highlight the g of x and the f of x when the inputs are the same. And there's our functions, the patterns. So we filled out the table according to the pattern, according to the equations. And so what that tells me is that if I have an input of -1, my output for f of x is -1. My output for g of x is 1. Okay. Now on the table, you use the inputs to find the outputs and then combine them. So say I do g of 1 plus f of 1. So I have my input of 1. My output for f of x is 3 when my input is 1. So f of 1 equals 3. Then my output for g of x, when I put a 1 in there, is 4. So g of 1 equals 4. So 4 plus 3 equals 7. I just combined these two graphs, essentially these two functions, to get a bigger number or function. Okay, in graphs, it's kind of that similar idea. So there's those if you need to pause and copy them down. Okay, so for the graphs, we're looking at the same idea. The x values are the inputs. We use that to start and see where to go on the graph. Find the y values. That's what we put into it. So let's zoom in here a little better so we can see. Okay, so we are going with f of 1 minus g of 2. So for f of 1, I go to the x-axis at 1. So this is where my input is. Then I'm going to find the function f. And apparently on my example, I did them backwards. So this straight line should be f of x. The curved line should be g of x. Oops, it happens. So that'll fix things. So for f of x, I want f of 1. So I go to the x value of 1 and I go down to my graph. Well, there's the point on my graph where x is 1. What is the y value? What is that point's y value? It's negative 1. So f of 1 equals negative 1. So I replace f of 1 with negative 1. Okay. Then, for my g of x, okay, we go 2. We want to know what g of 2 is. So I go to the x value of 2, find where my graph is. It's down here. What's that y value? Oh, it's negative 3. So g of 2 equals negative 3. So I replace g of 2 with negative 3. So negative 1 minus negative 3 gives us positive 2. If I take these two y values and combine them, we're up at a positive 2. Okay, when we combine them in that way. So there we go for the evaluating. There we go for the combining. And there's our frame.